All right, so like I said, we've been multiplying stuff together. We've been working with polynomials. Today we kind of reverse the entire process by factoring. So just so you know what factoring is, apparently my handwriting's not going to be good today. Factoring is when the process of breaking down a polynomial into two factors. I can hear you whispering.
Could you zoom in, please?
Yes. Oh, I am way zoomed out. Okay, so it is the process of, here's the problem is I can only move it so much because I can't get the phone. I don't know how I did it last week that everything was working nice and pretty and
Did you use like an iPhone?
now it's not. No, I had everything set up the same. Sorry, people watching from home. Okay.
Sorry, homie G's.
So, if we're breaking it down into two factors, hey, shush, that multiply, they multiply to make a certain product. And these are vocab words that we've kind of mentioned over the last couple weeks, but I just need you to know the difference between factors are things that are being multiplied. A product is what you get as the answer after multiplying. Mackenzie?
So like what we did with the division?
Yes, it's kind of like the division. So you know how when we were dividing, you knew one side of the factors and you just had to figure out the other one? Now we're not going to know either, which sounds a lot trickier than it is. Let's throw back to like an elementary school example. When you were in elementary school, you would have a number like 28, and we would start with maybe a product of 28 and ask you to break that into factors.
Oh,
so
like you do the tree?
Yeah, you can do the tree thing. I'm just going to look strictly for factor pairs. So what's one pair of numbers that would multiply together to give me a 28? Pink? 7 and 4. 7
Your name is not Pink.
times 4. Shh. Those are factors, okay? Carlos, what's another set or pair of factors that would make 28?
Is there another one?
1 and 28.
1 and 28.
Oh, yeah.
Thank you, voice who told Carlos it was 1 and 28. And what's another one I own?
4 and 7.
And also 4 and 7. So I've got 7 and 4. I'm not going to write 4 and 7
Oh, yeah,
reverse,
sorry.
but it really is the same thing.
2 and 16.
2 and 16 does not work.
2 and 14.
2 and 14. Oh, man. 2 and 14. So these are all factor pairs. Shh. These are all factor pairs that work together to make the 28, right? Okay. Well, here's an example of what it looks like in algebra. I might give you the factors of 2x times 4x plus 3. These are factors. 2x is a factor, 4x plus 3 is a factor because that's what's being multiplied together, right? I have 2x being multiplied by 4x plus 3. And what is the product of that answer?
It's 8x squared plus 6x.
8x squared plus 6x. That is the product.
Oh.
So here's what we start doing today. I'm going to give you the product, and you have to come up with the multiplication problem that would make that. You've done this before.
Yeah, you put it on your
It's been on the quizzes. That second period was like, we've been doing this. This isn't hard. So let's see. If I give you 30 minus 20x. That's not the one I meant to give you. I'm sorry. I don't want to start with that one. I have a reason why I don't want to start with that one. Let's start with, it's not hard, but it has kind of something I want to show you. How about 15x plus 20? Can you write a multiplication problem? And if we're just going to kind of go with distributing here. So I mean a distribution question that would end up as a product of 15x plus 20.
The 15x plus 20 is the.
I got one.
That's the answer. I want you, hey, calm down. I want you to write the distributive question that would have that as the answer.
Oh. I know I'm supposed to guess.
I figured because you had your hand up. Tunison, what'd you get?
5 distributed to 3 plus 4.
5 times 3x plus 4. Does that make 15x plus 20?
Yes, it does.
Yes, so I have two factors. I have 5 as a factor, and I have 3x plus 4 as a factor. I just broke that product into two factors that multiply together to make what it's supposed to make. Okay, so now let's look at that first one that I wrote. 30 minus 20x. Today's still all distributing. Okay, we're not going to do... Oh, yes.
That was a very mean question.
All right, she was
There was
polite about it.
attitude behind it.
Be quiet.
There was
All right.
attitude. Just
So I end up with 30 minus 20x is what I need to make. I need a question that would distribute to make 30 minus 20x. I want you to try and come up with at least two answers for this one. See if you can write two problems that would both multiply together to make 30 minus 20x.
I have one.
wait, 2 different problems.
Two different answers, like two different problems.
Oh, okay.
All right, Carter, you said you have an answer. What'd you come up with?
Okay. 2.
And then a parentheses thingy. 15 minus 10x.
2 times 15 minus 10x. Let's check him. Does that make 30 minus 20x?
Yes.
Yes, it does. Braden, what's another one?
Negative 1 parentheses negative 30 plus 20x.
Ooh.
Wait.
So let's distribute. Does that make 30 minus 20x?
Yes.
It does. Sync, what's another one?
5 distributed to 6 minus 4x.
5 distributed to 6 minus 4x. I get 30 minus 20x. Very good. What's another one, Red?
There's another
10 distributed to 3 negative 2x.
To 3 minus 2x. Do we have any other options
No.
1 second.
outside of just throwing a negative in there? What'd you say, Ayon?
Okay, wait, did I do this right? Okay, I'll check it after. 10 plus 2 times 20 minus 10x.
Say, huh?
You did like a really complicated one. So, okay, I'm going to write it. That's not what we're looking for right now, but you said 10 plus 2 times what?
20 minus 10x.
Times 20 minus 10x. She's that person who wants to really make sure that she gets full credit on
not
the
20,
quiz.
not 20, it's 10. Not 20, it's
10 where? Here in the middle?
10. Yes.
All right, so
20 plus 10. Okay, yeah.
if I did that, you would get 20 minus 20x, and then with the additional 10, that would make 30. That totally works. She's going more complicated than we need to. All right, all of these we've broken into factors. We confirmed that all of them make what they're supposed to make. One of these answers is just a little bit better than the others.
Mine.
And it has to do with the title on your notes.
Greatest common factor.
The greatest common factor. The 10 is actually the best option. Okay? That is because shush. That's because we're talking about the greatest common, we're talking about the greatest common factor. Hey, drop it. So at the top, I want you to be sure to label that GCF stands for the greatest common.
How do we know which one's the greatest?
I will give you some tricks. Okay? So you are looking for the greatest common factor. Now, there's a very easy way to know if you've got the greatest common factor or just a common factor. And here's how we can tell. Is if I look at this example, the first one with the 2, look at what's left inside. Do 15 and 10 have anything in common still? If they still have something in common, they still have a 5 in common, you didn't get the greatest one. Okay, what about 30 and 20? Do they have stuff in common? Yeah. Do 6 and 4 have something in common? A 2. So if you look at what's left inside the
like they're
parentheses and they still are multiples, like common multiples, then you need to keep going. 3 and 2,
1.
all they have in common is a 1. A 1 is not really relevant here, okay? All right, I'm going to stop right there and then do all the other examples in a separate video.